Hello, in this video we are going to define the interior of a subset of Rn, and we're going to explain what it is. Let's go through this definition. So let's start by letting S be a subset of Rn. So let S be a subset of Rn. And we will start by defining interior point. So a point P is called an interior point. Okay, an interior point of S if you can find some open ball around P that's contained entirely in S. So if there exists, let's say, an R greater than 0, such that the open ball of radius R centered at P is contained entirely in S. So that is the definition of an interior point. Now the set of all interior points of S is called the interior of S. So the set of all interior points of S is called the interior of S. Okay, so the set of all interior points is called the interior of S, and it's denoted by, and then you use a lowercase I, int, parentheses S. This is notation that is common. Or you might see S with a little circle like this sometimes. Note, just a quick remark here, a powerful one. This is one that is worth mentioning. Then we're going to look at a picture, and I'll try to explain what this is. The interior, okay, the interior of S is the largest open subset of Rn that's contained in S. So the interior of S is the largest open subset of Rn that is contained in S. Okay, so it is the largest open subset of Rn that's actually contained in S. Let me give you a picture here. So let's say that this is S. So what is an interior point? So an interior point, basically, if you look up here, it just means that if I pick a point P, I should be able to find an R such that there's an open ball contained there. So this would be an interior point. Now, what's not an interior point? Well, if I pick a point on the boundary, like if I pick a point right here, right, like if that point is on S and I pick it, it's not going to be an interior point because I won't be able to find an open ball. Now, it might be the case that that point does not belong to S, right? This could be like something like this, in which case the boundary is not included. In this case, this would be an open set, right? That's the intuitive idea. The interior of S is the largest open subset of S that is contained in S. So the interior is the set of all interior points. So think about this, right? Let's pretend this is S, right? So you pick all, and the boundary is included. So you pick all the possible points you can that are in the interior. So what's going to happen, right? If you pick the set of all interior points, we're saying it's the largest open subset of Rn that is contained in S. That makes sense, right? Because if you think about it, I mean, if you just try to like maximize all your points, pick infinitely many points, get closer and closer to the boundary, you would get the largest open subset that's in S in some sense. I don't know if that made sense, but that was my weak attempt to explain it. Hopefully you've learned some math in this video. Subscribe if you want to. This stuff is really beautiful. I have courses. They're on my website. They're actually on Udemy, but they're on my website. Check them out, mathsorcerer.com. Subscribe, all that good stuff. Like, share. Keep doing mathematics. Take care.